In this video, I will explain how to do a truth table in the software. And the way you're going to do it is not going to be necessarily intuitive. You would think that you would click on the thing that says truth tables and you would go do a truth table. Now, you could do it that way. You could enter your symbolization up here as a sequent, which means entering each premise gets separated with a comma, and then you put in the turnstile and put your conclusion. That's how you write a sequent. But that's the hard way to do it because you haven't checked whether your symbolization is correct or not. So you want to be able to do that too. So because if you're working from a bad symbolization, your truth table is going to be all wrong. So instead, you're going to actually start on the symbolization page. So remember, I said that you could check your answers to every exercise in the book, and that's true. You can check your symbolization to every exercise. So if you notice, like exercise 4, that's an argument, that's a proof, right? Chapter 2, exercise 4 is asking you to do a proof. So we'll come back to that when I show you how to do proofs in the software. For now, we're going to look at the truth tables. So we want to go to the truth table chapter. So that's chapter 10. Okay, so now when we put in a book exercise, I'm going to pick, I want to do exercise 5 because I want to do one that's reasonably complex. So I'm going to skip over the first few exercises. Okay, so the first thing it does is it tells me how many premises there are. That's helpful information just from the get-go. Okay, so this argument says so I'll just read the whole argument. The theoretical entities postulated by the particle theory of light exist if and only if those postulated by the wave theory exist. It is not the case that the theoretical entities postulated by both theories exist. Hence, it is not true that the entities posited by either theory exist. Okay, so that's a conclusion indicator. So we know that the last sentence is the conclusion, and so the first two are the premises. So let's do the first premise. By the way, if I didn't want to start with the first premise, if for some reason I wanted to start with the conclusion, I could do that just by pressing the down arrow. Lets me do that. The up arrow and the down arrow let me navigate within here. But I'm going to start with the first one. So that's the theoretical entities postulated by the particle theory of light exist if and only if those postulated by the wave theory exist. So that's P double arrow W. So see, that tells me already that that's correct. Then I hit enter, or I probably could have pressed the down arrow, and I go to the next premise. So it is not the case that the theoretical entities postulated by both theories exist. So that's a not both. So I'm going to do it's false that, and here I need parenthesis. Whoops, what are you doing? I'm not sure how I got on there. User error. Parenthesis P ampersand. Why? I don't know how I got there. All right. W. And then I need a close parenthesis or it's not a well-formed formula. So there we go. Yes, doing the down arrow works as well as enter. Okay, and so now I have the conclusion, which is hence it is not true that the entities postulated by either theory exist. So this is actually a neither nor statement. So again, I'm going to do negation, and I need parenthesis, and now it's P wedge W, close parenthesis. And so here you see that a couple things happen. So let's let's just watch what happens. A couple things are going to change. So I'm going to get a green check mark next to the statement. I'm going to get a smiley face that tells me I got the whole thing right. What happens if I press hint right now? Okay, so again, not very helpful. Just tells me there's more than one possible symbolization. Okay. So I'm going to get a smiley face, and then something else important is going to happen. We're going to get a whole bunch more menus under this bar. Okay, so let's do the close parenthesis. So you see how we got a whole bunch more options. So we could save this symbolization. If we wanted to, you can save it as a file. I don't know how helpful that is. It can only be opened, but it's a file that can only be opened by this program. So you can do that. You can save things. But honestly, if I was going to save this, I just write it down on a piece of paper, like, because you probably do want to do that. If you were going to like do this exercise in the truth table in Blackboard, you need to write all this stuff down. So I would probably just either take a screenshot or just write them down on a piece of paper. You could print them out. So that's the thing you could do, I guess. You could print them out and save them. That seems like a lot of extra work. Now we could go to proofs. We're given the option of going to proofs. I don't suggest that because we don't know this argument is valid. And so if we try to do a proof on an invalid argument, it's just an exercise in frustration. So I don't recommend that. And that isn't what you're being asked to do, but I apparently accidentally did that. Sorry. So if we go back to, can I just see how I can go back? Let's just go back to the symbolizations. Okay, I have to do it over again. Sorry, my bad. P, if and only if, W, not P, ampersand, W, close parenthesis, and then not P, wedge, W. Oops, I didn't do the wedge there. I did a V and a capital V at that, and that would not have been right. That would have told me it was not well formed. Okay. So now if I want to go, I could go to truth trees or truth tables. Both of those are actually fine options for this. And it might be that I might ask you to do a truth tree on this exercise as well, or instead of a truth table. I'm not sure what I did. But for now, we're just going to go to the truth tables. So it takes you to a truth table page with your argument all filled in. So you can see the sequent up here is as I described. So we have the premises separated by a comma, and then we have the turnstile, and then we have the conclusion. Okay, so this little menu pops up and it shows you what to do. It says left click on the blue question marks to make a check appear or disappear. Checks signify critical rows. I'll come back to that. Press the help button for additional information. Okay, so this will pop up every time that you do a truth table unless you ask it not to. So I'm not going to do that for now, at least. So I'm going to just say, okay, I got it. So basically what I want to do is I want to go through the truth table and just figure out the truth value for each statement. And so what it's done is it's helpfully, so here are your guide columns or your base columns. I forget what Pospesel calls them, right? But it's helpfully filled in the truth values for P and W on that row right underneath. And so this red question mark is going to be for the truth or falsity of that statement. So I click it once if I want it true. I click it twice if I want it to be false. So this should be true. So I'm going to click it again to make it true. Okay. So when we have a biconditional and one side is false and the other side is true, then it's false. So I'm going to click it twice to get false. And likewise here, we have one side true and one side false. They don't match, so it's false, according to the truth table for biconditionals. And here, when they're both false, then the statement is true because they match. And so you see, when I did that, the arrow turned green. That tells me that I got that row right. Okay, so this next one is more complicated. If I was to try to do this, like somehow doing, so suppose I thought, okay, well, P is true, so this negation must be false. And then, I don't know, what am I doing here? That's wrong. You do these last. So we're going to ignore that. You have to work from the inside out. So first we need to do, and you'll actually know which one you need to do last because he's put a helpful star under that one. So that's a good clue. That says basically, look here for your final truth value. So let's just concentrate first on the conjunction P and W. So that is true whenever both conjuncts are true, and it's false otherwise. So this first one is going to be true, and the rest will be false. So I'll click them twice. And as soon as I do this one false, see, right now I did it true. That tells me that something is wrong. Doesn't tell me which of these is wrong, but it tells me something's wrong. So now it turned green. So now I need to do the truth value of the negation. So it's going to be the opposite of whatever the truth value of the conjunction. So it turns out this actually is false. This is true. This is true. And this is true. Okay. Let's get some wrong. So you see it's wrong because it's turned back red again. But let's come back to that. I want some stuff to check at the end. I can't check it now. I can't check it till I'm completely done. Okay. So here we're looking again at the truth value for the disjunction. So P wedge W, just looking at that part of the statement, that's going to be true whenever one of the disjuncts is true or when both of them are true. So the only time it's going to be false is here where they're both false. And so these I can just do true. And then the truth value of this is going to be the opposite of the statement as a whole. So this line is going to be true. This is going to be false. And this is going to be false. Okay, then the question is this argument valid or invalid? So what I need to do is look under the main operator and see if we have a place where we have true, true, false. And actually, yes, that first row. So I'm going to put a check mark there. It says this shows invalidity. So this one is false, false. So I already know this is not a candidate. Here we have false and false, so not a candidate. Doesn't matter what the conclusion is. And here we have true, true, but then it's also true. But let's say, suppose I thought that that also showed invalidity. So I need to check all of the rows that show invalidity. And so the other ones, I'm just going to click twice and to leave them blank. Okay, so now, okay, it actually, so unlike some of the things like the proofs and the symbolizations, it gives you some hints and some feedback. So the proofs are going to give you some feedback and some help. This actually doesn't, I'm realizing. There's no way to check this. Basically, I know it's wrong because I've got these red marks up at the top. So remember, this one we made wrong on purpose. So which row was it? Here I've got the conjunction is false, and I say the negation of that is also false. So that should be true. So now that's all correct. This one I didn't do incorrectly on purpose, but I apparently did mess it up somewhere. And that's right here. So we have the disjunct is false at this row, so its negation should be true. Okay, so does that show? So now it's still not popping up a thing. It's supposed to pop up a thing. So I know that I've got something else wrong. So now the only thing left is these assignment of whether or not this row shows invalidity. So let's double check those. So here we have true. Okay, this is false. So this does not show invalidity. So I need to take that away. How about this one? True, true, but true. So this does not show invalidity. So actually, this argument is valid. And so it wants you to confirm that. So it wants you to show that you know what you showed. So it shows, so if I say that it shows invalidity, it says wrong, this sequence is valid. So it gives you some feedback that way. So that's how you do the truth tables. As with the symbolizations, there are practice problems. So if you want to practice some more, just to get the hang of truth tables more, you can click on one of these and you can do the truth table for it. Again, this is perhaps time well spent, both because practice is good, but also because these exercises might show up in a later timed assessment or learning module or something like that. So it could be worth your while anyway.